Good morning, everyone. Welcome to our Friday Convocation. It's wonderful to see your faces here, and we are thrilled to have Dr. Robert Koons here from the University of Texas at Austin to speak to us today on purpose in nature. Dr. Koons is professor of philosophy at the University of Texas at Austin, and he specializes in logic, metaphysics, and the philosophy of religion. He's the author of over 80 articles and of books, including The Paradoxes of Belief and Strategic Rationality, which he published in 1992, Realism Regained in 2000, and A Lutheran's Case for Roman Catholicism, which he published in 2020. He's the co-author of Metaphysics, the Fundamentals, which a number of you worked through with Dr. Skrzypek, and then also the Atlas of Reality in 2017, and the co-editor of The Waning of Materialism, Neo-Aristotelian Perspectives in Contemporary Science, and Neo-Aristotelian Metaphysics and the Theology of Nature. And his most recent volume is just out. It's called Classical Theism, New Essays on the Metaphysics of God. And we just had a rip-roaring time this morning discussing the first way, second way. He's even got a way to preserve the third way. It's just fantastic to have him here. Please help me to welcome Dr. Robert Koons.
Okay. Super. Thank you, Donnie. Yeah, thank you so much for the invitation, the invitation to be here. First visit to North Dakota, to University of Mary, of course. Heard a lot of great things about what you all are doing here, and everything I've seen so far confirms what I've heard. Wonderful people, great hospitality. I'm very envious, really, in a lot of ways, of your faculty to have the kind of students that I've seen here and the coherent curriculum that you get to enjoy. University of Texas is a little different in some respects, but I won't go into that today. So I'm going to talk about purpose in nature. And let me see if I can find my thingamajig. Yeah, here's a little bit of an overview. So I'm going to use the word teleology a lot. Philosophers like to talk about purpose in these terms. First of all, because teleology is kind of a cool word, and we don't get to use it that often. And also because if you use the word like teleology, it means that you're really serious about purpose. It's not scare quotes purpose, like serious, real purpose in nature. So I'm going to talk a little bit about that in Aristotle and Aquinas. Real briefly, some history about the great rejection of teleology, purpose in the early modern period, so-called scientific revolution. And then I'm going to go through this. It's going to be really quick, I'm afraid, through the sciences, starting with physics and chemistry, thermodynamics, biology, psychology, and then finally argue that this puts the human condition in a different picture once we have all that purpose in nature as a form of a background. So in teleology in Aristotle and St. Thomas, the crucial thing here is to understand that for Thomas and for Aristotle, the world of nature is a world that's suffused with power and potentiality. Things have powers to do things and potentiality to change in certain ways. And this brings with it already a notion of teleology. There's really nothing much more to teleology in Aristotle and Aquinas than the notion of power. The notion that you have a power to bring about a certain result or the potentiality to be changed in a certain way. So just to give a simple example, you think of an electron with its negative charge, right, has the power to repel other negatively charged things, right? And what that gives you is a kind of intentionality, as George Milner puts it. That is, the electron just sitting there with this negative charge is sort of indicating that if any other negatively charged things come along, it will be repelled, right? So it's referring to a possible future, and it's indicating that certain futures are preferred over other futures. That's teleology, right? That's really all you need to have teleology in Aristotle and Aquinas. And so if you have powers and potentialities in nature, you've got teleology according to this picture. So the difference between intelligent and unintelligent purpose on this picture is just a difference between the way in which a thing has the end that it has. So the electron has certain ends, right, of repelling things and attracting things. It has it in an unintelligent way. It doesn't do these things because it knows it's good, right? Whereas human agents do things, and God ultimately does things because we believe they're to be good. So it's just a different way of having ends. It's not that we have ends and the non-intelligent things don't have them. But of course, historically, we see a kind of rejection of this, which already begins in the late Middle Ages, even with Scotus and Occam, a notion that, well, really only human beings and things above us have purposes and intentions, and not things in the natural world. With Francis Bacon, we get the explicit banning of teleology from science, right? And this turn from teleological explanation to quantitative explanations in terms of momentum, force, and energy is then the heart of the so-called scientific revolution. And you see, for instance, a turn to also about the same time, a kind of pragmatism. So it's another important difference that occurs this time. Descartes talks about how it's possible to attain knowledge which is very useful in life instead of the speculative knowledge, philosophy, which is taught in the schools, right? We may find a practical philosophy by means of knowing the forces and the action of fire, water, and so on, we can control things. So from a world in which science was aiming at contemplating, understanding, and appreciating nature primarily, we move to a scientific project which is now about controlling things, right, for human purposes. And from that perspective, you can see why understanding the purposes of things becomes unimportant, right? We don't really care what the purposes of things are. We have our purposes. We're going to control them to make them work for us, and we don't care what their internal purposes were themselves. This reminds me actually of a line in The Abolition of Man by C.S. Lewis, where he talks about a need for a kind of regenerated science. And one of the things he says there is that regenerated science wouldn't do to minerals what modern science does to human beings. And so there'd be a kind of respect for teleology, I think is what Lewis is talking about there. And that's definitely something we lose in the scientific revolution. So some other things that happen at the same period is we get an introduction of matter as something that's independent of form substance. So before this, matter and form are correlative terms. You can't just talk about matter. You have to say the matter of this substance, right? Informed in a certain way. Already with Scotus and with Occam, we start talking about just matter as such, as though it had a kind of nature that could be studied in physics. We get the replacement of causal powers with abstract laws of nature, right? Which itself I think is a theological notion, actually. It comes from Basil of Caesarea. But it's an important move in the sense that it moves us away from teleology, because again, powers give you teleology. If you get rid of powers and just see science as describing mathematical patterns, right, then you're moving away from the notion of purpose in nature. And then related to this, we start getting a very strict sort of bottom-up explanation in science. So we explain things in terms of their parts rather than parts in terms of the whole, right? And that also then is something that begins to constrict the realm of purpose to the microphysical level, and deprives other natural things like organisms and people of having a kind of intrinsic purpose. Let's see if I can pick up this next point. So in particular in biology, we get a move away from teleology even there, right? Bernard, French biologist, philosopher, says, vital properties are only in reality the physiochemical properties of organized matter, right? And Bernard also says, the final cause does not intervene as an actual and efficacious law of nature, right? So final cause referring to teleology, right? And again, Bernard is already assuming that science is just about laws of nature. And so if you don't refer to purpose in your law of nature, then you have no purpose, right? And since we don't do that in biology, there's no purpose, even in biology, this picture, right? There's just the physical chemical properties that make up living things. Now, nonetheless, having said this, after the scientific revolution, biology continued to be unapologetically teleological in many ways, right? But then Darwin's theory of evolution was often taken to be the crunch here, in which any kind of teleology was going to be abolished. And this is, again, the Huxley quote I have on the slide here, that which struck the present authors most forcibly in the Origin of Species was the conviction that teleology, at least as commonly understood, has received its death blow at Darwin's hands. So the thought was that Darwin shows how nature is just physical, chemical objects operating according to laws of nature, and every kind of a purpose or teleology or function is just an illusion, appearance of this underlying functionless and purposeless physical background. Okay, so, but nonetheless, there's been resistance within philosophy of biology and among biologists as well. For instance, you find in biology that teleological language persists throughout all of biology. I mean, pick any biological text, any article, any textbook, give me any page, and I will find you many, many examples of teleological language on that page, right? So what is a gene, right? Is a gene, well, it's a DNA molecule. No, it's a DNA molecule with a certain purpose, right? Namely coding the construction of proteins. What's an enzyme? What's a protein? No, it's a protein with the purpose of catalyzing a certain kind of reaction in a cell, right? What's a cell? What's an eye? And so on. What's reproduction, right? It's the generation of a new organism of the same or roughly the same kind as the parents, right? That what's a kind, right? In biology, kinds are defined functionally by their teleology, by their way of life that they're trying to pursue. So teleology, and Haldane, this is somewhat politically incorrect quote these days, I guess, but Haldane, a famous biologist, atheist, said, teleology is like a mistress to the biologist. He cannot live without her, but he's unwilling to be seen with her in public. You often find this when you talk to biologists. They'll say, oh yeah, I mean, yes, I'm using teleological language, but don't take it seriously. It's merely a heuristic, right? And I have to say, okay, a heuristic to what, right? Heuristic means it's something that helps you make new discoveries. But in biology, all this heuristic language helps us make new discoveries in biology, which is more teleology, right? So in fact, you never escape teleology, right? It can't be heuristic for something else. Teleology has to stand on its own right, even within biology. And the reason for this has been pointed out by a number of, especially sort of neo-Kantian philosophers. Georg Töpfer, a few years back, had an article along these lines, says that teleology is closely connected to the whole concept of an organism. And therefore, the very definition of biology is a science. So unless there's teleology, there aren't organisms. If there aren't organisms, there's no biology, right? So there's something inescapable about teleology for biology. In addition, if there's no teleology in the world, then what do we do about human beings, right? We're also organisms, right? If there's no teleology in nature, the kind of move that Descartes and Bacon tried to do, in which you would just shrink teleology down to human beings and leave the nature devoid of teleology, isn't going to work anymore, because that requires a kind of dualism, right? As though the human soul is something separate from nature, which brings teleology with it. Modern scientists doesn't want to believe that. I don't want to believe that either, right? And so if nature is devoid of teleology, so are we, right? And eventually we have to apply the same kind of reductionism even to human agency. And already Socrates in the Phaedo, right, objects to this and says, wait a minute, if you try to explain my behavior just in terms of, he talks about bones and sinews and muscles, we could throw neurons in there as well, right? Chemicals in the synapses. You've left out the most important thing, which is, I'm here because the people of Athens thought it's best for me to be here, and I thought it was best to go ahead and accept the punishment, right? So in other words, Socrates is complaining, look, without teleology, without purpose, you can't make sense of human activity. So we need to go back here and figure out how are we going to solve this problem. So what I'm going to do is going to argue that really things have changed dramatically with the quantum revolution. I'm going to talk more about this this afternoon. So I'm going to go through this part real quickly, skip over a lot of the technical details. So I hope you can come back to 3 if you want to pursue some of those in more detail. But essentially, what my view is that had we discovered the quantum phenomena in the 17th century, then we never would have left Aristotle at all. We would have said, "Oh, Aristotle's got it right, exactly," and none of this anti-Aristotelian, anti-teleological stuff would have happened. Right? We would have gone straight from one to the other. This is definitely a minority viewpoint at this point, but I'm gradually collecting converts to this view. So I hope I can pick up a few more here while I'm here. Now let's go to basic physics for a moment. So classical mechanics can be formulated in one of 2 ways. We can do it in terms of differential equations using Newton's equations. So we're thinking about the pushing and pulling of bodies by forces, right? Or you can do it in terms of integral equations, the conservation of energy, and particularly the minimization of action, right? The so-called least action principle. These are equivalent in classical mechanics. And the typical reaction of people when they discovered this was to say, Newton's stuff shows you what's really happening. The least action stuff is kind of an interesting artifact that's helpful in solving equations, but it's not like real, right? Because and Leibniz recognized this. Leibniz said, wait, the least action principle, that's teleology, right? You're saying that the system finds the path that's the best path for it to take and then takes it, right? That's explicitly a teleological notion, right? And so what do we see then when we look at the history of philosophy? We find that, of course, we no longer think that Newton's laws of motion are the accurate representation of the physical world. We've gone through multiple sort of mini revolutions, right, since that time. Despite all those mini revolutions, least action principle survives in some form or other. That's been the most robust, the most resilient part of modern physics, is this least action idea. So teleology, as Max Planck noted in his book on physical reality, teleology is triumphant in the quantum world. Quantum physics has vindicated Leibniz and vindicated the idea that there's something deeply teleological about science. You see this, for instance, in Feynman's Sum Over Histories account of quantum mechanics, which again, explicitly teleological in its nature. Okay, now this is the part, again, I'm going to go into some more detail this afternoon, but I want to spend a little bit of time talking about chemistry and solid state physics and thermodynamics. Okay. I think from the point of view of quantum theory now, we can see that those sciences are actually the fundamental sciences of the inorganic world. Particle physics is not fundamental, right? I can argue that in some detail. In terms of history, it was very important for us to discover quantum phenomena through the study of particles. But in the end, what we've learned is that there's something going on in the world of chemistry and thermodynamics that is irreducible to the particle level, doesn't even supervene on it, to use a philosophical term. So there's a real autonomy to the realm of chemistry and thermodynamics, which brings with it a whole new set of teleological phenomena, right? So in thermodynamics course, we talk about entropy, second law of thermodynamics. I argue that turns out to be a fundamental law of nature, right? It's not just some sort of byproduct of deeper principles. It's a fundamental law of nature. So things that are thermodynamic in character seek greater entropy. They're heading towards a kind of equilibrium point. That is, in a something like a strict Aristotelian sense, the good of the inorganic substance to reach high entropy, right? It's I think we get confused about this sometimes because we think of entropy as as a sort of disorder, so that if we go to increase disorder, that's actually a misconception. From the point of view of inorganic things, right, high entropy is exactly the sort of peaceful state that Augustine says we're all seeking, right? It's the peace of an ordered tranquility. That's what chemical and thermal substances are seeking. Now, for you and me, high entropy is bad, right? Because if I reach a high entropy state, I'm dead, right? But that's exactly the difference between organic and inorganic things, right? Inorganic things are properly seeking high entropy. That's what's good for them in a fairly strict analogous sense. There's teleology there, right? Already in that realm. So again, I'm going to skip over some of this just for sake of time today. There's a distinction here between two kinds of models in quantum mechanics. Separable and non-separable models, involving whether there are finitely many or infinitely many subsystems in the model that we're looking at. And what happens is that when you try to do quantum chemistry or quantum thermodynamics, it turns out that the simple sort of models we started with, the separable or finite models, are totally inadequate. There's something called the Stone-von Neumann theorem that says that any two representations within those kinds of models have something called unitary equivalence. Right? Which means that they can't be used to represent different macroscopic states, like the difference between solidity and liquidity, or between ferromagnetism and non-ferromagnetism, and so on. And in particular, you can't in quantum mechanics get spontaneous symmetry breaking, which happens all the time in classical physics. But once you get to quantum physics, you can't get it unless you go to these non-separable models. What does that involve? The non-separable models require something called the continuum limit. Okay, which means that you have to model the system as if there are an infinite number of infinitesimally small particles. That gets you the additional mathematical structure you need to get inequivalent representations, which you could then use to represent spontaneous symmetry breaking and all these other things. So this actually, again, confirmation of Aristotle, right? Because what it's suggesting is that matter is actually continuous, right? That is, that the particle character of it, atoms and molecules and so on, are really virtual. They're in the realm of potentiality. To represent what's really going on, you have to represent it continuously by means of these non-separable models. Okay. So that's an interesting fact. Now, there's three reasons for taking such an infinite limit, right? One way would be for mathematical convenience, right? I'm trying to solve some equations. If I go to this infinite model, I get rid of some of these terms and it'll simplify the calculations. A second reason would be just to isolate some factor that's from others. So maybe I'm in a situation where friction is sort of irrelevant, so I'm going to just pretend friction is zero, take it to a limit, right? A third reason is because if you don't take it to a limit, you don't get enough mathematical structure in your models. Going to the continuum limit in quantum thermodynamics is a case of this third kind. And that's really important because in the first two cases, you could say the limit is just a fiction. Right? It's just a useful fiction. In the third case, it's not a useful fiction, right? Because the thing that you're going to use to explain the phenomenon only appears when you go to the limit. So you have to take the limit ontologically seriously. Right? You have to take it as representing something that's really going on in nature and not simply something for our convenience. So again, you don't get spontaneous symmetry breaking without, in pioneered quantum mechanics, if you were to balance a pencil on its tip in simple quantum mechanics, it won't fall in one direction or another. It will fall in all directions simultaneously, right? So to speak, right? There's no symmetry breaking. To get symmetry breaking, you have to go to the continuum limit. You have to go to non-separable models. You get what are called super selection sectors, right? Such that you can move from one to the other. You don't get phase transitions. So Jeffrey Sewell's done a lot of work on this, starting in 1986. I remember when I was at Princeton doing a sabbatical, I discovered his work back in about 14 years ago, and it was like the light came on. I suddenly realized, yes, this is crucial. So what Sewell and then Liu and Ritchie and others have pointed out is that without going to this continuum limit, you don't get phase transitions. You don't get, so if someone says, okay, continuum limit is just a fiction, then you're saying that the liquidity of the water in this bottle is a fiction, right? The difference between liquid water and water vapor and ice is just a fiction. Well, no, it's not, right? I mean, we've lost our touch with the reality. We start thinking those things are fictions. Those are real phenomena that have to be explained. They can only be explained at the continuum limit. The continuum limit requires this sort of model. Now, what does this have to say? I'm going to skip over molecular stuff, but the same point arises here. In simple quantum mechanics, the Schrodinger equation is totally symmetrical, spherically symmetrical in space. And so it doesn't bias you in one direction to another. So you don't get an explanation of why you get a right-handed molecule in some cases and left-handed in the other cases. You go to the continuum limit, it's no problem. You can have spontaneous symmetry breaking. You get molecular stability. So you actually get something in chemistry then, in quantum chemistry, that we can call the chemical form of a substance, right? And it's really identical to the substantial form of Aristotle, right? It's something that grounds the classification of that chemical substance. It's something that grounds the persistence of chemical substance over time. It's something that grounds the substance's active and passive powers. So the crucial point here is it's top down now, not just bottom up. Something doesn't belong to a particular chemical form because the particles are arranged in a certain way in space. It's really the other way around. You get a form that determines the substance's chemical form. That then guarantees that when you interact with it at a particular level, at a microscopic level, it will manifest itself in a certain way, right? So the molecular form of the individual parts is something that dwells in the realm of potentiality, right? What's actual is the form. That's the idea. And if that's true, then again, the kinds of purposes that we see in chemistry and thermodynamics are real purposes in nature, right? So again, the second law of thermodynamics, and the way that we in chemistry we look for stable states for the molecules, and if they're seeking the low energy state, that's not just some mathematically useful shorthand. That's what's really going on. Chemical substances are seeking those better states teleologically. That's a fundamental reality. Okay, and that gives us lots of interesting facts. It gives us a direction to time, right? So if the second law of thermodynamics is a fundamental law and not just some kind of statistical fluke, then it points direct time into a particular direction. That's extremely helpful for various reasons. Okay. Let's see, how am I doing time-wise? Not too bad. Okay, so I want to move on to biology and psychology real quick. And I'm going to sort of put these two together, right? So there are a number of problems that the materialist faces, who wants to say that, look, it's all just physical, or even all physical and chemical, right? One problem is how to account for the qualitative aspects of the world, the so-called qualia problem, secondary qualities, colors, and so on. How do they fit into the world? How to explain the intentionality of sensation, intention, and thought, the way that we think about things that aren't here or don't exist yet, and how to account for the apparent teleology of living organisms and of persons, right? And I'm going to focus really on the second and third of these. I'm going to set the qualia problem aside here today. Just focus on the second, third. So how do we deal with those? If you're a materialist, how do you deal with these two problems? The most popular way is something called functionalism. Okay, so functionalism is the modern, sophisticated version of behaviorism, right? Behaviorism said to be in a certain mental state or to have a certain biological property or state is just a matter of a function from environment to behavior, right? So to believe something is just to be such that if you're in a certain environment, you act a certain way. Okay? Well, that turns out not to work for lots of reasons. But what functionalism does is it adds another dimension to it. So it's not just function from input to output. It's a function from internal state and input to output and new internal state, right? And once you add that extra element in there, now you can use things like computers as models for the mind or for living organisms, right? You can do something called Turing machine kind of computationalism and all that. So my point is just that functionalism is a descendant of behaviorism, but it's a super sophisticated version of behaviorism, right? But the objections I'm going to raise today, which are based on a paper that Alex Pruss from Baylor and I wrote in 2017 in Jonathan Jacobs' book on causal powers, our objections apply to any version of functionalism, no matter how sophisticated. Right? So they're very general arguments against this kind of functionalist strategy. Okay? So how does this work? Frank Ramsey and David Lewis are two people who developed this in some great detail. These are generally now called Ramsey sentences because of Frank Ramsey, a British philosopher of science. So what you do is you take a science like biology or psychology, and you replace all of the explicitly biological and psychological terms, like belief, sensation, desire, reproduction, gene replication, whatever. Replace all of those explicitly biological or psychological terms with variables, X, Y, Z, and so on, right? And then you stick a bunch of existential quantifiers in front. There is an X, there is a Y, there is a Z, there is a something or other, such that these X, Ys, and Zs have certain causal relationships to each other, right? So in other words, what we do is we figure out how do these mental or these biological states relate to each other causally. That represents a certain pattern of interaction, right? And then we extract that pattern, right, by getting rid of all the biological, psychological terms with variables, stick existential quantifiers in the front, right? So we're saying there are some properties, they're all physical properties, right? There are some physical properties such that these physical properties have these interrelationships with each other that realize the pattern of life or of mind, right? That's the strategy, okay? Now the question is, what does this theory look like? Well, it's going to have conditionals in it, right? It's still going to be conditional. It's going to say, if you're in this kind of input state and you have this kind of, and you're this kind of internal state, then you will go to this output and you will go to a new internal state, okay? But the question is, what kind of conditional is this? Because there's at least three different possibilities. One would be just an indicative conditional, right? If you're in this state and that state, then you'll be in this state and that state. The second possibility is to go subjunctive, right? If you were in this state and that state, then you would be in this state and that state. And the third place would be to say, let's talk about powers. If you're in this internal state, then you have a certain power, which in response to an input will cause you to produce a particular output. So the third one is explicitly power ontology, so to speak. And in other words, you could actually end up with an Aristotelian version of functionalism, which was explicitly teleological because the powers were teleological, okay? So the modern functionalist is not gonna like that, right? So 3 is out, right? They're gonna have to go with something like 1 and 2. But 1 doesn't work at all, right? Because 1 means that if somebody never encounters a particular kind of input state, right, then they're just going to automatically satisfy all of the conditionals, right? So if my clicker here never finds itself in the relevant kind of internal state, then it's alive and has a mind and so on. Just by default, it will automatically verify all the conditionals. So we want to use the counterfactual conditional. We want to say, if this clicker were in the kind of state that I'm in when I'm seeing you, then it would. Of course, it can't be, right? So you have to go subjunctive, and that's going to be the crucial to the argument, I guess. Okay, so let's introduce something called the Harry Frankfurt's hypothetical manipulator. Okay, so. Here's the picture. You and I are alive and we have a mind, okay? We actually satisfy probably the conditional, the second version of the conditional. We're the sort of things that if we were in a certain kind of state, we would respond in a kind of appropriate way, right? But suppose that there's this manipulator out there, some super Martian guy who's observing us, right? And the Martian wants me to live a certain kind of life in detail. He's written out a script. So what my life is going to be like in detail. Now, it turns out, just by chance, the script he's written out is exactly the life I'm going to lead anyway, right? So he never actually does anything. But if I were to deviate from that script in any way and be put in any kind of situation other than the one I'm actually going to be in, the manipulator would come in and change me around and make me do weird stuff, right? Stuff that would not be reflective of having a mind or being alive at all, right? So if you put me in that situation, right, then I will still live exactly the same life I live now. Nothing will ever actually interfere with me, but all the counterfactual conditionals will be false now, right? Because if I were in these other situations, the manipulator would come in and change things and I wouldn't behave appropriately, right? So the question is, would the mere existence of this detached hypothetical manipulator be enough to deprive me of mind or of life? No, right? No way. And so that shows there's something fundamentally flawed with this sort of definition. Now, there's various moves you could make. And the only move that's going to work for the functionalist would be to say, well, wait a minute. When I proposed this idea on this slide, number 2, implicitly what I meant was, if the system X were in that state and you got an input I, and everything is normal, right? Then, and of course, manipulators are not normal, right? So we have to add some kind of normality condition in order to make functionalism work. I think that's pretty well recognized now. Normality is going to be needed. But what can the normality be, right? It can't just be most people this is true for, because then I just have manipulators for everybody, right? So now the statistics won't work, right? So you got to say, no, there's something intrinsically abnormal about a manipulator of this kind, right? Well, maybe you could say the manipulator has to be internal to the person. You could have just a little tiny manipulator inside a brain, right? Or something like that. And there's all kinds of ways to get around that, right? So there's really, I think, only one possible move here that the materialist can make. And that is to say, to bring in evolution, okay? And to say what's normal is when my adaptations are functioning in the way that they were selected to work evolutionarily, right? And this indeed has been the whole project that's been developed in recent years by Ruth Barrett-Millikan, and a bunch of other people, which is to try to use evolution as a way of defining normality, right? So something is supposed to work a certain way, right? And then you just add that into the conditionals, right? If the input and the internal state are there and X behaves the way it's supposed to work, then such and such happens. What does supposed to work mean? Well, it means that you're part of a reproductive family that has worked a certain way in the past. And because your ancestors worked that way in the past, they were able to survive, and that's why you're here, right? So the idea is that we use the facts about the actual facts of my evolutionary history to tell us what is normal or what's not normal for me, okay? All right, so Proust and I, again, tackle this in the same article. And we argue that, look, there's huge problems with this kind of proposal, any proposal along these lines, right? First of all, evolution requires reproduction, right? To have evolution, you have to have reproduction. To have reproduction, you have to have organisms. To have organisms, you have to have teleology. So in other words, it's viciously circular, right? Any kind of Millikan account is circular. The Millikan likes to talk about duplication, but in the biological world, nothing ever perfectly duplicates itself at the physical or chemical level. What it does is produces another organism of the same kind, and that's all individuated teleologically. And so there's no way this can work, ultimately. Secondly, it has the weird effect that purpose and, well, that life, function, purpose, and so on are always at least one generation after the structure that has the purpose. So in other words, suppose there was this first living organism, right? And it produces some daughters and so on. Millikan has to say the first living organism was not alive because it didn't have any evolutionary history. Only its daughters could be alive. Even if the daughters are exactly alike it not alive, right? And likewise, the first thing that was conscious, well, no, only its children could be conscious. The first conscious thing had to be unconscious, right? And that's bizarre, right? It also leads to a weird sort of epiphenomenalism where she has to say that consciousness has no effects as such. Then thirdly, it makes functioning, life and consciousness, weirdly dependent on causally irrelevant facts in the past. And so here, this is Alex Proust's idea. I'm borrowing his idea of a thought experiment, another weird thought experiment. So it's the second and last weird thought experiment, so don't worry about it. If you don't know philosophy, you should know we love weird thought experiments, right? It's crucial for our progress. This one is the Great Grazing Ground thought experiment. So again, you've got a duplicate of Earth in some other galaxy, okay? History there is exactly like history here, point by point. Our duplicates are in that parallel Earth, having the same talk and so on, right? In that parallel Earth, though, there are some hyperdimensional beings who, for some reason, hate to see things die and fail to reproduce. So as soon as something's about to die, they whisk it off into another dimension and put it in the great grazing ground, and they keep it, they restore it to life and health, and they make sure that it reproduces itself as many times as possible. So in that parallel Earth, every organism that's ever existed has the maximum number of descendants. They've all succeeded in reproducing themselves perfectly, maximally, right? In that world, natural selection has done nothing whatsoever, right? Nothing was ever selected for in that picture. Therefore, Millikan's account doesn't apply. You can't say what's normal, what's abnormal. Therefore, nothing on that Earth is alive or has consciousness, right? Because actual selection is not working, okay? And what's really weird about that world is not only exactly like ours, the great grazing ground doesn't interact with the world at all. They just whisked off to this other great grazing ground. They never come back, right? So nothing that's causally relevant is different in the two worlds. And yet, in that world, no life, no consciousness. In our world, consciousness and life. And this is just a very vivid way of bringing out the fact, right, that purpose, life, consciousness can't be extrinsic to me. It's got to be something to do with me, not about my ancestors and what might have happened to their descendants and so on, right? It's got to be something more intrinsic to me, and yet all these Millikan accounts don't do it. So we're really forced, that third option, an Aristotelian account of normality, which means we have to think that there are fundamental powers that are biological. Sensation is a fundamental causal power, right? Intention is a fundamental causal power, right? We're not just pushed around by our particles, it's the other way around, right? We do things biologically, personally, that affects our microscopic structure in various ways, not vice versa. Not that there isn't interaction in both directions, right? Obviously, if my body weren't made of carbon and hydrogen and so on, I wouldn't be able to be alive. If you replace it all with aluminum, I'm dead, right? So there's an interdependency there. But it's not the case that all the action is at the microscopic level, right? That I think we have to eliminate. So finally, if all this is true, right, then human beings appear on the scene, right? We now are in a world that's much friendlier to purpose, right? Because purpose has already been there at the pre-biological level, at the biological level, right? And now we're just adding a new level of purpose and teleology to that, right? So it makes a lot more sense, right? We're not forced to think, as Sartre, I think, thought, was that we're some kind of eruption of non-being, right? In a world that's meaningless and purposeless and so on. We're really building on a biological and even pre-biological foundation. And so now we can use teleology as an account of knowledge, right? What is it to know something? It's to believe something in such a way that your cognitive powers were functioning properly in a normal environment, right? What is it to be happy? It's that your moral and cognitive and cognitive powers are functioning properly in a normal kind of environment and so on. So we can give an objective, science-friendly, in a sense, account of ethics and of epistemology, ultimately. So I'm going to stop there, and hope we'll have some time for questions. So thanks.
Thank you very much. Question, early in your talk, you talked about entropy, and you mentioned how entropy seems to be good for inorganic things, whereas it's clearly not good for us. Given that we are made of the sorts of things for which entropy is the good, how can it be the case that entropy is, and sort of the peaceful Augustinian state for them, is a good for them, but are being dissolved into that same peaceful state would be bad for us?
Well, I mean, a couple things, right? One is we're just of a fundamentally different kind of being than they are, right? So our telos is radically different from the telos of an inorganic thing. So that's a simple sort of answer. Slightly more involuted answer might be to point out that living things also depend on entropy, right? I mean, the chemical reactions that take place in our cells that sustain our life are themselves driven by the usual kind of chemical mechanisms of seeking, low energy states and so on. So I think this idea that we all have, at least I had, entropy bad, right? That's super wrong, right? We have to not think that way. It's at least neutral, right? And actually, in many cases, good for us and good for the inorganic things as well. I mean, I'm being a little provocative by saying it's like good for the water in the jar in the bottle to reach an equilibrium state. But I mean, it's sort of true, right? Because I mean, for Aquinas, right, the good is that which everything seeks. Inorganic things seek this kind of equilibrium. That's good for them, in a sense.
Here's a follow-up. Does your account here help us to explain how we come to know what the purposes of things are? And if so,
Yeah.
and these purposes are everywhere, how could we ever fail to know what our purpose is as human beings?
As human beings, right? So I mean, two crucial questions, right? Well, how do I know the purposes of other things, right? Ultimately, it's by discovering their most fundamental powers, right? And that really involves, observation, experimentation, all the usual kind of stuff, right? Does that apply to human beings too? I think so to some extent, right? But of course, in this case, we get to have the little inside information because we actually are human beings, right? And so, you can do the sort of thing that Aristotle does in the Ethics, right? Look at what ordinary people, what wise people think the human end is, refine that under philosophical scrutiny and so on. And I think that's all helpful. I mean, I've had conversations with folks like in the New Natural Law movement, the Grisey sort of tradition, Venice tradition, and they of course want to say, it's all internal, right? You just reflect on the human condition phenomenologically or something and to grasp the good. You don't get to use biology or anthropology or anything like that. I'm much more open to empirical evidence being relevant here, to finding out, look, human beings function best when the family is organized a certain way. That's probably good for human beings then, right? So I think you can, in my view, you can use empirical study of human condition to fill in some of the information or to confirm, most cases, just confirm what we already know.
Hello, thank you. I feel like I've missed a major point because it's not quite clear to me the distinction that you're trying to make between understanding the powers of something and understanding a natural law. So you use the example of the electron, right? That it has the power to sort of repel or attract something, where I might describe that as the electrical force. And it seems like you're saying that as two different things, and that's fundamental to your argument. Is that true?
Yes, I think so. I have to qualify a little bit. I mean, obviously, they're very closely related things. And someone like myself who believes in causal powers can also believe in laws of nature. But the difference is that we think the laws of nature is dependent on the causal powers and the way they're distributed. Whereas folks who think that there are laws of nature, so there's three camps, right? There are those who say, really, there are no laws of nature, no powers at all. It's all just an illusion, right? That's the sort of Humean tradition. You can say there's laws of nature, but there are no powers, right? You can say there are powers, and therefore, because there are powers, there are laws of nature. So Coulomb's law is just a way of expressing how the powers of charged particles express themselves, manifest themselves, on my view, right? Whereas on the other view, you would say, no, let's not talk about powers. They're just these laws. I mean, it's going to get us a little bit into some of the philosophical technicalities here, because the difference between the first and second view is somewhat subtle. But typically, people in the second view would say that the laws of nature are contingent, completely contingent. So God could have made a world where Coulomb's law was changed by some completely different law. My view would be, well, in order to do that, he would have to produce something other than charge. It would have to be charge or something. It would have to be some other property that brought with it other properties that would satisfy some other law, right? So it's a slightly subtle difference. So in my view, if there's charge, Coulomb's law is true, is a necessary truth, right? Whereas it wouldn't be on the other view. Yeah.
If I can just follow up quickly related to Donnie's last question as well. Does this particular move to causal powers and teleology open us up in a little more susceptibly to the is-ought fallacy in nature? Do you know what I'm saying here?
Yeah, sure. Yeah, right. So let me say a little more. I want to back up too and say a little bit more about the powers issue as well, because this is something I didn't get a chance to go into in the talk, so I'm going to use the excuse here to introduce it. Pre-quantum, right? You could treat any kind of so-called potentiality or possibility as a mere thought experiment. It's just something to sort of play around with as a possibility. Because to explain what's going on in the world, all you need is what's actually happening and the laws of nature, right? That's it. Once you go to the quantum world, as Heisenberg observes, potentialities take on a reality they never had before. You have to start taking potentialities seriously as parts of the world. And that taking potentialities seriously as parts of the world is indeed this whole idea of causal powers. And again, that's what brings teleology back into the picture. So I want to say that, get that out there. Now, what about is-ought fallacy, right? Yeah, so I mean, I'm definitely in the camp that says there is no is-ought fallacy, right? That ought is itself part of what is, right? And so in fact, if you describe human beings accurately and exhaustively, your description will entail all kinds of oughts, right? And whereas again, in a non-teleological picture, that would be false, right? Describe human beings exhaustively, you know, protons, neutrons, electrons, and so on. You fill all that in, no ought's going to come out of that, right? So there is I think a deep difference there. That's right. Doesn't mean that everything that is right, right? Because human powers are things that can be thwarted in various ways and can be distorted by bad environments and whatnot, right? So we all have certain natural powers to cooperate justly with other human beings, but things interfere with those powers such that we don't actually do it. We don't live justly as we should. So, but ultimately, there's going to be an ontological foundation to make that distinction, right? Why is justice good for human beings? Because of the kind of things we are, because it fulfills our nature, and that nature expresses itself in these fundamental powers. So, yeah.
So could you pull up the slide quoting Haldane about the mistress again?
Sure.
Okay. While you're doing that, let me say, you've sort of broken my heart because I think I'm going to have to read your book. And I don't have really time to do that. But let me try to play devil's advocate here. So I'm going to try to do that by paraphrasing Democritus. So isn't the upshot of this slide that we could say something like, by convention, enzyme, by convention, gene, by convention, organ, by convention, reproduction, by convention, injury and disease, but in reality, atoms and void?
Yeah.
And doesn't this solve the functionalism? Like, all those slides just go away, right? If it turns out there aren't really any organisms.
Yeah, but so does mind, and so does thought, and so does intentionality. Right, so yeah, I mean, sure, that's an option, right? So if you want to be an eliminativist about biology and psychology, there are no minds, there are no living things. You can be a physicalist, you know, that's fine. I mean, but that to me, it's not a popular route to take, right? And I think there are some questions here about whether that's even pragmatically possible to adopt that viewpoint, right? I mean, I know the moves, right? I mean, I would say, look, you believe there are no beliefs. You say, well, no, I don't believe there are no beliefs, but nonetheless, I sort of believe there are no beliefs or something, right? So I know the dialectic there, and I'm not, to be honest, I'm just not that interested in going down that particular rabbit hole, right? If you want to go down that rabbit hole, okay, fine. Or this devil's advocate does, fine. I'm confident that most scientists and most philosophers and most ordinary people are not going to want to go that way. But if you have I mean, there's this problem, right, with democracy too, because convention, what's convention, right? Convention seems to imply
it's a comment.
People.
It's not a quit.
Convention seems to imply people doing things, right?
I just have to break it to you. Philosophers are not ordinary people.
No, I know. Those were exhaustive categories. That's right. Yeah.
On that note, let's thank you for an extraordinary talk.
Thanks. Thank you.